All right, gang, here we go. Chem 1, Unit 8, Part 2, talking about percent, actual, and theoretical yield. Okay, hopefully the last part didn't melt your brain too much doing stoichiometry. Now we're just going to tack on another thing to it. All right, this is really not that difficult, but it's a really important skill, especially when we're doing our labs in class. We'll do an entire lab just based around this idea. Okay, so yield. Remember, yield is the specific term chemists use, to talk about how much they've made, right? Or like, remember we talked about, two things combined to yield, right? So it's how much you've made, okay? And really we want to be able to specifically figure out how much we made and how good our reaction was, right? So there's three different types of yield I want you to know. First is called theoretical yield. Okay, the theoretical yield is defined as the maximum amount of product that can be formed under ideal conditions, and usually this is in grams. Okay, it can also be in moles or volume. Okay, it can really be in anything we can measure, but most of the time when we talk about, we're really talking about grams, because grams is really easy to measure. You just take your thing, stick it on your balance, and read it off, right? So that's why we stick with grams most of the time. So essentially, when you're thinking about theoretical yield, this is what, okay, the math says. Okay, so this is really in the previous unit, or the previous part when we were talking about stoichiometry, you figured out, specifically in that problem where you figured out how many grams of bromine we could make. Okay, specifically that was the theoretical yield. That's what the math said. This is how much bromine we could make. Okay, all right. So that's the theoretical maximum amount. Okay, the actual yield is the measured amount of product actually formed. So the actual yield, that's super easy. This is what you got when you were doing the lab. Okay, so if theoretically you did the math and you said, okay, we should have made 200 grams of water. Okay, but then when we measured it, we found we only made 190 grams of water. Okay, so that leads us to the percent yield, and the percent yield is simply a way of quantifying how close you were to the actual yield, or the theoretical yield. All right, so it's like figuring out your score on an exam. Okay, you take your actual yield divided by your theoretical yield and multiply it by 100. So like, think about it this way. Theoretically, if you were perfect at chemistry, you would have gotten 100 out of 100, or you would have gotten, there were 100 possible points on an exam, and if you were perfect, you would have gotten 100 out of 100, so your percent yield would have been 100%. Okay, but if you were only 80% perfect, that means you got 80 out of 100, right? So essentially, we're just plugging things in and dividing them, multiplying by 100 to get into percent. All right, so let's do a practice problem here. Super easy. Chlorobenzene, C6H5Cl, is used in the production of many important chemicals, such as aspirin, dyes, and disinfectants. So here's the reaction to form chlorobenzene. You take benzene here with chlorine gas, you get a chlorine on there and hydrochloric acid out. It says, what is the percent yield of chlorobenzene if 36.8 grams of C6H6 reacts with chlorine and 38.8 grams of C6H5Cl is actually made? Okay, so we want the percent yield. Remember, the formula for percent yield, okay, was the actual, okay, divided by the theoretical times 100. Okay, so the actual yield, okay, they tell us with this, it says is actually made. So that's the 38.8 grams. All right, so that's the 38.8 grams of our chlorobenzene. All right, so that's our actual yield. Now we need to figure out the theoretical yield. Now they don't give us the theoretical yield, do they? They only tell us that we started with this much benzene. Okay, that's C6H6. So we have to figure out what the math says. We got to dust off our stoichiometry skills, figure out how much of this we could have made theoretically. All right, so we got to go back to our mole map. We got to go from mass to mass. So we're going to start up top, flip over to part 1, look at your mole map. We're going to go from mass of benzene down to moles of benzene, use mole ratio to go to moles of chlorobenzene, and then up to mass of chlorobenzene. All right, so here we go. So we're starting with 36.8 grams, okay, of C6H6, right? And then we're going to go to moles. So this is a 3-stepper, okay? So we're going to go to, right, because we're making 3 moves here. So we're going from grams of C6H6. I always recommend writing in the units first, okay, to moles of C6H6. All right, so that's our first step. That's grams to moles. Now we're going to go moles to moles. So we're going to go from moles of C6H6 to moles of our chlorobenzene. That's the C6H5Cl. And then finally, and remember our theoretical and actual yields needs to be in mass. So we're going to put moles of C6H5Cl in the bottom and grams of C6H5Cl in the top. All right. So now we got to start filling in our numbers. Okay. So here, well, this is a molar mass value, so we got to figure out the molar mass of benzene. Okay, so C6H6. So I'm just going to label it here so I can keep track of what's going on. So I got 6 carbons, 6 hydrogens. We're going to add all those guys up. Okay, so 6 times 12.01 times 6 times 1.01. All right. So 6 times 12.01 plus 6.06, 78.12. All right, so 78.12 grams per mole. All right. So for every 1 mole of this, we get 78.12 grams of benzene. Okay, now we do our mole to mole ratio. So we got to use our coefficients. But first we should just double check to make sure this is balanced. Always be warned, if you look at this thing and there's no coefficients on whatever reaction I give you, there's a good chance that it's not balanced. All right, so you got to make sure it's balanced. So we got 6 carbons, 6 carbons, 6 hydrogens, 5 plus 1, 6 hydrogens, 2 chlorines, 1, 2 chlorines. All right, so it is balanced. Okay, so that means everything's got a 1, so it's just a 1-to-1 ratio. That's nice. Okay, now we're going to go from moles of chlorobenzene to grams of chlorobenzene. So that's our C6H5Cl. All right, and we got to figure out the molar mass of this thing. So we got 6 carbons, 5 hydrogens, and 1 chlorine. All right, all those guys up. So 6 times 12.01 plus 5 times 1.01 plus 1 times our chlorine, which is, just let me double check, 35.45. All right, 30.45. All right, so we're going to add all those guys up. So 6 times 12.01 plus 5.05 plus 35.45, get 112.56. 112.56. Okay, 6, I got ahead of myself, grams per mole. All right, so we're going to plug that in. For every 1 mole, it weighs 112.56 grams. So now we're going to do our math here. So we take 36.8. Remember, if it's on the bottom, it divides. If it's on the top, it multiplies. So 36.8 divided by 78.12. Okay, times 1 divided by 1 times 112.56. So we got, plugged it all in, so we got to think about our sig fig. So that's got 3, so our answer should have 3. So we'll round to 53.0 grams of C6H5Cl. Now, remember, all of that is just stoichiometry. That's what you learned how to do in part 1, right? And so we're going to take that. That is our theoretical yield. So we're going to take that value, plug it in up here for our percent yield. So that's our 53.0 grams. All right, so we'll take our 38.8 divided by 53.0. We get 70.73. Oh, we forgot to multiply it by 100. Whoop, times 100. Okay, times 100. Okay, so we get, and 3 sig figs here, so 73.2% yield. All right. So what this is saying is that we should have been able to make 53.0 grams of this chlorobenzene, but for whatever reason, and there could have been a variety of different errors, okay, we only made 73.2% of what we should have made. And that's essentially all we're after here. Okay, so when we do our lab in class, you should be able to use this. You're going to be making sodium chloride, okay, and so you'll be able to figure out how much you should have made, or how much you should have made, and how much you actually did make, and then find the percent yield there. All right, so we'll do lots of practice problems. Again, this is a really important skill moving forward, so let me know if you have any questions, and I'll see you on the flip side.